Hello, I am Joel Conte, Professor of Structural Engineering at UC San Diego and in charge of the upgrade of our large outdoor shake table. So I would like to give you a tour of the upgrade, construction side of the upgrade, and focus on some important points. So let's go. So here we are at the Engelkirk Structural Engineering Center. We are arriving, we are pointing west. You can see here a large tent. We had to build these tents to store a lot of equipment, several hydraulic equipment mainly, since the upgrade is taking quite some time. It started, the project of the upgrade started on October 1st, 2018 and will end in late spring, summer 2021. Here you see the safety towers that we use when we are testing some specimen to prevent them from collapsing. All right, and here we are turning towards our staging slab. We had a second tent earlier here on that slab as well, but now you can see these two big packages that contains actually the two new horizontal actuators. Now we are walking back towards the shake table, and you start to see the platen of the shake table that is resting on four large reinforced concrete columns that were built just for the temporary storage of the platen. The platen weighs about 145 tons, and it will require some work. We require some drilling of many holes to install the new wear plates underneath, and we have to do some machining on the underside of the platen to provide ideal surfaces to slide over the vertical actuators. And as we turn south, you can see the hydraulic power building. It's the same building that we had the last 15 years. It contains all the hydraulic power supply and the controller of the table. So we are going to have an overall look at the inside the reaction map. So you see a number of things here, a lot of piping, and the red pipes is the one that will have the pressure, the main pressure pipes. The red pipes, if you follow them, they follow a ring. We call this the main pressure ring. And the blue pipe are the return pipes. When the shake table will be working, the fluid inside the red pipe will be at 3000 psi. Inside the blue pipe, the return will be probably below 100 psi. You see, these are gigantic pipes. They have a 12-inch diameter inside diameter. They are 1.25 inch thick. You also see a lot of smaller pipes. The smaller pipes you see red, blue, and yellow. So these are the pilot. The red and the blue are the pilot pressure red, pilot return blue, and the yellow one are the drain pipes. I'd like you to observe, these two walls that each of them support three vertical actuators. You see the steel base plate that will support the actuators. You notice that the plate that are at the end of each of the wall, so four of these plates, they had to be extended because in the 6-degree of freedom upgrade, the four corner vertical actuators have to be moved in by 10 inch to accommodate the new kinematic capabilities of the platen. So here you see the platen. You see these two large steel plates that will receive the head of the horizontal actuators. In the 1-degree of freedom configuration, they used to be fixed here. And now in the 6-degree of freedom configuration, there will be one horizontal actuators fixed here and the other one connected here. We are going to go under the platen to show you surfaces over which the vertical actuator will slide, the top of the vertical actuator. So you see these surfaces, they had rusted in the last 15 years. We just grit blasted these areas. And you see the one in the middle here. So there is 3 on each side. We are going to install some very large wear plates, half-inch thick wear plates, highly polished, and we will have to maintain a planarity of plus or minus 24 thousandths of an inch of each of these 6 areas. Now under the platen here, you can see 2 very large, the 2 large saddle blocks that will allow to anchor the top of the hold-down strut. Right? And we will have a new one in the middle. You can see that the one in the middle has never been used, in yellow here. And then at the other end of the platen there is the existing one. So we will have 3 hold-down strut to keep a very large overturning moment capacity. Here I would like to show you the northwest corner of the reaction mass of the shake table. You can see here that we are in the process of post-tensioning the large steel plate that serve as a base for the horizontal actuators that I'll show you in a second inside the reaction mass. But you can see here 6 post-tensioning rods with the nuts and the plates, washers. And you also see that we have grouted the volume behind the plates, between the plates and the reaction wall. And now we're going to go and look at these large steel plates that are inside the reaction mass. So you see one of them here that has been positioned. It has, now what needs to happen is we need to do some surveying work to have all the accuracy in the final positioning and then grout the spacing between these plates and the reaction mass. And we have 4 of those because now we're going to have 4 horizontal actuators. You can see the location of the other 2 that we will work on very soon. And now we are going to go inside the building, see a number of crucial things. We are going to look at, we have 2 new pumps to supplement the existing 2-1. And we're going to look at the new accumulator bank that is completely installed, and a lot of the new piping inside the building. So let's go. All right, so here we are turning around the west-south corner of the hydraulic power building, and you will see the 2 new pumps, brand new pumps that are being added to the existing two pumps. And you can see that we had to, of course, connect them to the cooling system. We have a new cooling tower. You see the brown pipes there for the cooling system, and also bring the electrical power here. And now we are going to see next to this the brand new accumulator bank, very large accumulator bank, 75 bottles with a total volume of 10,000 gallons. So here you see they are in a group of 5 bottles. So we have 15 of these sub-modules. You can see that every bottle is monitored for the pressure with wireless pressure sensors. And this is basically these 2 pumps that you have seen. They are going to be used to mainly pressurize the accumulator bank, to push some oil at the base of each of the bottom, below the piston, until the nitrogen pressure, which is above the piston, reaches a pressure of 5,000 psi. In idle conditions, the pressure of the nitrogen in the bottle is 3,000 psi. So about 20-25% of the bottom of each bottle will be filled by oil. And that pressurized oil is the one that is used to control the horizontal and vertical actuators when we reproduce a multi-dimensional earthquake ground motion. And here below the catwalk, you can see clearly some red pipes. So the pressurized oil that is inside the accumulator bank is released through some blowdown valve, released into these red pipes, pressure pipes, that connect to the one that we have seen inside the reaction mass. And you also see here the blue pipes, and that's the return pipe, and you can see that they return the fluid at low pressure all the way to the surge tank. You see this large surge tank, we did not have to change it. We had sized it properly 15 years ago, thinking about the upgrade. All right, so now let's go and look at the cooling tower. We had to completely replace the old cooling tower that was close to the end of its life. Number one, and number two, didn't have the cooling power required for the upgraded shake table. So behind me, you see the cooling tower for the 4 powerful pumps that we have in the system. You see a lot of circuitry here, a lot of pipe for the water, and the electrical system support the cooling tower. Look at the size of the cooling tower compared to the building. It's pretty appreciable. We're going to go on the other side now. So here you see the 2 blue tanks here. It contains chemical that prevent calcification inside the heat exchangers of the pumps. This is a problem that we experienced in the past, and we don't want this to happen in the future again. So let's go inside the building. So here we have a very good view of, first, you see the 2 existing pumps. So one of them is going to continue to serve as the pump that is feeding all the pilot flows to control the spool of the servo valves. And the second pump will be also used to pressurize the accumulator bank. So we will have 3 pumps to pressurize the accumulator bank now. You see the top of the accumulator bank. Again, these modules of 5 bottles each, 15 modules, 75 bottles. You can see again the surge tank here. It's a 20,000 liter surge tank. So now we are going to go downstairs and go all the way to the bottom of the building to appreciate the size of the accumulator bank from their footing and the surge tank, and also follow the path of the oil from the accumulator bank all the way to the reaction mass. So now here you see the incredible height of this new accumulator bank, and again the surge tank from below. And you see the 2 pressure pipes. Most of these pressure pipes were prefabricated by GS Hydro in Houston. One link that had to be welded in the site here is the one that I'm showing you here. So you see these 1, 2, 3, and 4 big weld, circular weld. Same thing for the second pipe in the back. These took a long time, and they had to be x-rayed as all the other weld. And these are, again, huge pipe, 12-inch diameter inside, 1 1/4 inch thickness. So you see, again, there they are coming out of between the 2 accumulator banks here, which release the oil through some blowdown valve that we can see here in the view of the camera. with the 1 degree of freedom configuration, we used to have only one of these pressure pipes, and we had to double it. So now we are going to enter the tunnel, and you can see below these 2 red pipes, there are also 2 blue pipes that are the return pipes. You see that the tunnel is now occupied hugely by these 4 large pipes. Now we are entering the reaction mass. You can see here the joint of the foundation of the building and the reaction mass. So we're on the south side of the reaction mass with a tunnel that brings the 1 pressure pipe and 1 return pipe towards the east, and then on the other side towards the west. And now we are inside the reaction mass. We have seen it a few minutes ago from above. So now you can see the big wall, the large wall here that is supporting 3 of the vertical actuators. You can also see the steel base plate that will support the vertical actuators. As I explained earlier, 4 of them had to be extended. You can see the extension here with rebars welded to the plate and anchored down to the concrete. We still need to grout this. We had to do this because the vertical actuator now in their new position will be 10-inch more on the inside than before to accommodate the kinematic capabilities of the Platen with the new horizontal actuators. You can see here many of these large blocks called hydraulic manifolds. And at the bottom again, you can see now closer than before, again the red and the blue pipes, but you can see these large blocks with 3, 4, 5, 6, 8, 16. Each of them has 16 orifices, and these will allow flexible hose to bring the high pressure fluids to the servo valve of the horizontal actuators and get the return. And you can see here again from very close one of the gigantic steel plate to which the horizontal actuator will be anchored. So the swivel base of the new horizontal actuator will be bolted to these two plates protruding out that you can see here. This plate has not been grouted yet. Very shortly, in the next week or so, we will grout them against the reaction mass after a very accurate positioning. I'd like to bring to your attention, you see this opening into the reaction mass. First of all, the tunnel through which we came, and then you have the door on the west here, the door on the north, and the other door towards the east. This reaction mass has tunnel inside. It's not a solid block of concrete. Also, would like to show you this middle area between the 2 large walls supporting the vertical actuators. You can see these catwalks, and so we are going to replace the 2 hold-down strut that were here in the last 15 years. You can see here on the video the saddle, one of the 2 saddles that is anchoring the base of the hold-down strut to the bottom of the reaction mass. We will need to bring a 3rd hold-down strut that has already arrived. You can see it here. Under the blue tarps, we have the 2 existing hold-down strut, and under the brown tarp, we have the brand new one that has arrived on site a few months ago. And now that 3rd one will be anchored down in the same way as the other 2 in the middle to increase the overturning capacity of the shake table Platen. So this concludes our virtual tour of the construction site of the upgrade of the LH post to 6 degree freedom. We will call the facility the LH post 6. We are right now on course to reopen the facility in July 2021. Very sorry that you could not be here in person. It would have been nicer. We hope that you will have a chance to come soon, before it reopens or soon after it reopens. Thank you very much for your attention.